Hello, my name is Elisha Jr., and my project is called Energy Storage Levels of Different Types of Supercapacitors. The purpose of my experiment was to determine which type of supercapacitor could store and utilize the most energy in a short period of time. The independent variables were the type of supercapacitors used. A lithium-ion battery was used as a constant variable. The amounts of energy each supercapacitor could store were the dependent variables, which were represented by unfinished model cars powered by supercapacitors. If pseudocapacitors are used, then they will store the most energy because they use the reduction-oxidation reaction, which can be used to store high values of energy, was the hypothesis for this experiment. I found out in my background research that supercapacitors are capacitors with higher capacitance values than regular capacitors, meaning that they can end up using more energy than regular capacitors. But they have lower voltage limits than other capacitors, meaning that the sources of their charge are limited. Their main competitors are batteries, but both batteries and supercapacitors have strengths and weaknesses. In the market, supercapacitors' main weakness is that it is very expensive compared to batteries for a lower amount of storage power. While batteries' main weakness is that they have chemicals which make them unpredictable and cause them to charge slower than supercapacitors and last a much shorter time. I also found out that there are three types of supercapacitors: double-layer capacitors, pseudocapacitors, and hybrid capacitors. The double-layer capacitor stores energy electrostatically. All supercapacitors have four things. They have a right electrode, a left electrode, a separator, and a liquid electrolyte. The right and left electrode are oppositely charged, and when they receive charge from voltage, become attracted to each other, but due to the blocking of the separator, cannot come together. Due to this, they exert their electrostatic force onto the separator. When the force becomes too strong, the separator will transfer it to the electrolyte, where it will become electrostatic energy, which can then be discharged. The pseudocapacitor charges differently. It charges electrolytically. The pseudocapacitor stores energy using the reduction-oxidation reaction. The reduction-oxidation reaction, or redox, consists of reduction, which is when an atom gains an electron and becomes more negative, oxidation, when an atom loses an electron and becomes more positive, and reduction oxidation, when one atom gains or loses an electron, and another atom gains or loses or gains electrons. And then when this happens, when all of the charged atoms then begin to move through in between the electrolyte and the electrode after being charged, that will then transfer each of their charges between each other through friction. This will then cause electrolytic force, and then the electrolytic force will move through the electrolytes, becoming electrolytic energy, which can then be discharged. The hybrid capacitor combines both the values of electrostatic and electrolytic charging techniques to store energy, manipulating both the double-layer capacitor and the supercapacitor's powers, making it often larger than the other two. I used, for my materials in this experiment, one double-layer capacitor, one pseudocapacitor, one hybrid capacitor, one ScienceWiz energy experiment kit, one stopwatch, one AA battery holder, two AA batteries, one lithium-ion battery, and it has to be the exact type because the lithium-ion battery I used could be attached to the motor, and one roll of double-sided tape. Basically, what I did for my procedures, I attached the car frame to the motor, and I attached the wheel to the motor. And basically, I used the double-sided tape to do that. And then, basically, using the AA batteries inside of the AA battery holder, and I started with the double-layer capacitor. I would then attach the double-layer capacitor's wires to the motor, and then I would attach the AA battery holder to the motor. So basically what happens is the AA batteries will charge the supercapacitor. I allow it to charge them for 5 seconds, then I remove the AA battery holder from the motor, and the AA battery's wires have to be touching the capacitor. And then the charged capacitor will then run the motor for a certain amount of time. The amount of time that the motor runs after you remove the AA batteries is how long that the supercapacitor was charged enough to be able to cause the motor to spin. I would then record that time using the stopwatch and repeat that process 10 times, putting back in the AA batteries and removing them over and over again. I would then repeat this with the pseudocapacitor, hybrid capacitor, and lithium-ion battery. The results in statistics: the pseudocapacitor ran for an average of 50 seconds, while the double-layer capacitor ran for 11, and the hybrid for 60, and the lithium-ion battery for 41 seconds. This shows that the hybrid capacitor ran for the longest, while the double-layer capacitor ran for the shortest. The pseudocapacitor had a median of 48.5, the double-layer capacitor had a median of 12, the hybrid capacitor a median of 59, and the lithium-ion battery a median of 41.5. That is the middle set of data for each of the variables. Meanwhile, the pseudocapacitor had a mode of 39 seconds, while the double-layer capacitor had a mode of 13 seconds. And that 39 seconds was the most repeated set of data for the pseudocapacitor, while 13 was for the double-layer. The other two sets of variables actually never repeated the same data twice. On the right, I have a chart showing the times for each of the variables in each trial. And on the bottom right, I have a chart comparing each of the running times to each of the variables. Based off of the chart, you can tell that pseudocapacitors and hybrid capacitors are obviously the strongest sets of the variables. In conclusion, the original hypothesis states that if pseudocapacitors are used, then they will store the most energy because they store energy using the reduction-oxidation reaction, which can be used to store high values of energy. The hypothesis is unsupported by the data because, on average, the hybrid capacitor actually stored more energy than the pseudocapacitor. The revised hypothesis would be that if hybrid capacitors were used, then they would store the most energy because they combined electrostatic and electrolytic methods to store energy. The lowest average out of the data was the double-layer capacitors, showing that they had the least overall energy. The range in data for the double-layer capacitors was also the smallest, so based on this, you can assume that they are the most predictable. Some of the limitations that may have affected my project were the fact that fingers touching the wires may have resulted in conduction of energy, which may have not caused things to become more or less charged. The most obvious error would have been with the stopwatch, as it is impossible to exactly time the amount of time that something would run in seconds. Other errors could have been with how there were delays in taking the wires out and putting them back in, and how the batteries may have worn down over time, causing there to be lower results due to the fact that batteries wear out quickly with their chemicals. The project is useful in the real world because supercapacitors could be a safer and easier replacement for batteries, as batteries have chemicals that can hurt the environment. For example, if you put a battery in the ocean and a supercapacitor in the ocean, the battery will be more harmful because of the chemicals that it can release. Based off of the data, in this experiment, we can tell that supercapacitors actually do stand a chance in competing with batteries, while many people are afraid to buy supercapacitors due to their cost. Supercapacitors could allow people to charge their phones quickly or provide power to places where there are power outages more quickly than batteries could, allowing people to get their lights back. In the future, more types of capacitors can be used than rather strictly supercapacitors. Rather than creating a small version of a model car, large car engines can be used for supercapacitors to replicate a car driving on the street. We could test other sources of power. We could test different temperatures. We could test the supercapacitors for more charging time than just 5 seconds. This would all be research that may or may not affect the supercapacitors. The purpose of this experiment, again, was to determine which type of supercapacitor could store and utilize the most energy. The independent variables were the types of supercapacitors used. A lithium-ion battery was the constant variable. The amounts of energy each supercapacitor could store were the dependent variables, which were represented by model cars powered by supercapacitors. The hypothesis was, if pseudocapacitors are used, then they will store the most energy because they store energy using the reduction-oxidation reaction, which can be used to store high values of energy. The procedure consists of building a a model car and attaching it to a supercapacitor and a lithium-ion battery and observing how long it can charge the motor from running after being charged for 5 seconds. In the end, the hybrid capacitor was able to store the most energy on average, while the double-layer capacitor stored the least, leading to the revised hypothesis that if hybrid capacitors are used, then they will store the most energy because they combine both electrostatic and electrolytic methods to store energy. Thank you.